nodal analysis, using basically nodal analysis and determine what about I0. So first of all, solve everyone, try, then I will do. Okay. First of all, try everyone, then after that I will do. Okay. After that I will do. So first of all, try everyone. After that I will do. Okay. I hope so. I know that if you apply nodal analysis, according to fundamental concept of nodal analysis, say take branch current in, first of all, what about first step? First step is determine branch current. Okay, mention branch current. That here I1 in this branch, here I2, whatever be the direction, I3, and that branch current already given, and that branch current already given. So first of all, what about branch current? All branch current mention. I1, I2, I3, I0, and 2 billion here. Now second step, node voltage decided. That one is V1, that one is V2, and that one is V3, and that one is V4. Okay. After that, one node take as a reference node, means 0 voltage. For simplicity point of view, if this one taken 0 voltage, then that one is also 0. Why? Because of no any source connected between these two, or any resistance connected in between these two terminals, and we are assuming here that one is an ideal wire. So means potential difference between these 2 points are 0. It means if this one is V3, then that one is also V3. If this voltage is 0, then that voltage is also 0. If this voltage is 2, then it is also 2. So we are assuming here 0 voltage, then also 0 voltage. Okay. So clear or not? Why we have taken 0 voltage? So if this one is 0 volt, so this one is also written 0 volt. After that apply KCL. There are two nodes, this one and this one. So apply KCL at node V1 and V2. Okay. What about incoming current? No any incoming current here. Okay. No any incoming current here. So first of all, write now equation. Everyone write now equation. Okay. Then I will. What about I1? What is the relation between I1, I2, and I3? Okay. Simply no any incoming current at that node. So what about KCL? KCL say sum of incoming current this equal to sum of outgoing current at any node. So I1 plus I2 plus I0, this is equal to 0. I1 is basically written. What about I1? I1 is V1 initial voltage, and that one is final voltage 0. Current leave from negative terminal, so -6 divided by how much resistance? 4. Plus what about I2? I2 is V1 minus 0, V1 minus 0 divided by how much? That is 4 kilo ohm. And what about I0? I0 is V1 minus V2, V1 minus V2 divided by how much? 4. This is equal to 0. This is equal to 0. Okay. After that, if you take LCM, then we got 4, 4, 4. So V1, 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 that is 3 V1 minus V2. This is equal to 6 volt. Equation number 1. If anyone faced doubt, then tell me, I will discuss again. If anyone faced doubt, then tell me, I will discuss again. Okay. If anyone faced doubt, I will discuss again. If anyone faced doubt, Comment it, I will discuss again. I hope so. Everything is okay. Everything is okay. So 3v1 minus v2, this is equal to 6. That is equation number 1. Now apply KCL at node v2. Incoming current, sum of incoming current I0, outgoing current I3, plus how much? 2 milliampere. What about I0? That is V1 minus V2 divided by how much? 4 kilo ohm. What about I3? V2 minus 0 divided by 4 plus 2. If you take LCM, then V1 minus V2, this is equal to V2 plus 8. So V1 minus 2 times V2, this is equal to 8, equation number 2. Okay. Now, our motto, determine I0. I0 means if you determine V1 and V2, then we got I0. Okay. After that, put that value, then we got I0. So that one, if V1 is put in equation number 1, what about V1? V1 basically 8 plus 2 times V2. That value put in equation number 1. Then we got how much? 3 times 8 plus 2 times V2 minus V2, this is equal to 6. So that is 24 plus 3 into 2, that is 6, minus V2, this is equal to 6. So 5 V2, this is equal to minus 19. So V2 this is equal to minus 19 divided by 5 volt. After that, that value put here V1. So V1 is 8 plus 2 into minus 19, minus 38, minus 38 by 5. Minus 38 by how much? 5. So we got 2 divided by 5. V1 is how much? 2 divided by 5 volt. Okay. So what about V0? V0, V1 minus V2 by 4. So 1 by 4, V1 minus V2. V1 is 2 by 5. Okay. And what about V2? V2 is plus 19 by 5. So how much? That is 21. 21 divided by 4, 5 are 20. So 1.1 volt. Sorry, milliampere. Closer answer is 1.1 milliampere. Okay. Closer answer is 1.1 milliampere. If anyone faced doubt, then tell me. I will discuss again. That is 0. This one is basically written. That is 1.05 milliampere. Okay. So if anyone faced doubt, then tell me. I will discuss again. If anyone faced doubt, then I will discuss again. Okay. If anyone faced doubt, then tell me. I will discuss again. Okay. Otherwise, make it. Otherwise, make it. I will explain again. If anyone faced out, then tell me. Sir, why put V1 in this equation? Because our motto determine V2. So if you let join, then I will repeat. Our motto determine I naught. So first of all, we have taken branch current I1, I2, I3. After that, node voltage V1 and V2, and that one is V3, V4. According to, and after next step, one node take reference node. If one take your reference node, we have taken that one voltage 0, so that one is also 0. Why? Because both have same potential. After that, apply KCL at that node I1, V1 and V2. I1 plus I2 this plus I naught this equal to 0. Okay. I1 basically written V1 minus 0 current leave from negative source, so minus 6 divided by how much resistance? 4. So divided by 4. After that, what about I2? V1 minus 0 divided by 4. And what about I naught? V1 minus V2 divided by 4, this is equal to 0. After that, take LCM, then 3 times V1 minus V2, this is equal to how much? If this one is going on here, that is positive, so 6. Equation number 1. Now next target is apply KCL at that node. Incoming current I naught, here I3 plus 2, written like that one. I naught is V1 minus V2 divided by 4, and that one V2 minus 0 divided by 4, and that is 2 milliampere. After that, take LCM. Then V1 minus V2, this is equal to V2 plus, if multiply by 4, then we got that one. After that, if this one going on here, then V1 minus 2 V2, this is equal to 8. So if what about V1? V1 basically 8 plus 2 times V2. If this value put here in equation number 1, then we got 3 into 8 V2 minus V2, this is equal to 6. 3 8 ja 24, 3 2 ja 6, and that is minus V2, this is equal to 6. And that one is 6 V2 minus V2, that is 5 V2, and that one 6 minus, that is 18. That is 18. Silly mistake, minus 18. Okay. So V2 is written how much? Minus 3.6. Okay. Minus 3.6. Now that value put in equation number 1, V1. Then what about V1? V1 basically 8 plus 2 into minus 3.6. That is 8 minus 7.2. That is how much? 0.8. That is V1. So if that value put here, I naught is V1 minus V2 by 4. V1 is how much? 0.8. And V2 is how much? 3.6. So plus 3.6 divided by 4. That is how much? 36 point, that is 4.4 by 4. So 1.1 milliampere is the right answer. This was the right answer. Silly mistake in previous. Okay, so recheck again, and we got final answer is basically 1.1 milliampere. Okay. Why put V1 in the equation? Because of, if not put in which equation? If V1 put in equation number 1, then we got V2. If we put in equation number 1, then we got V2, and after that, that V2 put again in that equation, then we got V1, and our motto determine I naught. So put here V1 minus V2 divided by 4, then we got final answer is 1.1 milliampere. I think your doubt is clear. If you're not clear, then tell me again. Okay. I hope so. This one is clear. Now, next problem. Now, I've taken another problem also. I hope so. Clear. So, next problem is this one is a voltage source. Sorry, we have taking another color also. That one is a voltage source. Okay. And here, that is resistance. A resistance like that one. A current source adding here. Okay. Another resistance connected here, and after that again a resistance connected here. Okay. Our motto determine V naught. Our motto determine V naught. Okay. And that one is positive and negative, and current direction given like that one. That one is 6 volt, and that is 4 kilo ohm, and that one is 12 kilo ohm, and that one is how much current? 2 milliampere. Okay. And here 4 kilo ohm, and here 12 kilo ohm. Our motto determine V naught. Our motto determine V naught with the help of nodal analysis. Nodal analysis. Using nodal analysis. If mentioned with the help of nodal analysis, Thevenin's theorem, Norton's theorem, whatever be the theorem, then always apply that theorem or according to that one. Otherwise, your question answer is right, but your method is wrong. If your exam say using nodal analysis determine V naught, so using nodal analysis, not other method. Okay. So first of all, try everyone, and after that I will do. After that I will do. Okay. So I hope so. Everyone try. Determine V naught. Everyone try. Everyone try. If anyone face doubt, okay. I am clear. So, okay, thank you. I think clear picture. Now, so how can do? First of all, if you see very carefully, according to question say using nodal analysis. So first of all, we have considered branch current. We have considered branch current. Here I1, here I2, okay. Here I3, here I4. So I4 current also here because both are in series. That's why. And that current already given. So now next target is node voltage. This one is V1. So that one is also V1. Why? Because of this, that one, no any source connected in between. So that voltage and that voltage are same. And that is V2. And here that is V3. Okay. After that, next step, if you using nodal analysis, so 1 volt take reference voltage. So that one is 0 voltage. So that one and that one also 0. Okay. So what about V2? What the relation between these two? If this one is V2 and that is V0. If anyone faced doubt, then first of all make here that plus minus V0 and here that is 0 volt and here V2. Okay, what is the meaning of that one basically? Here plus minus V0, here plus minus, here plus minus. What is the meaning of that one? That is V2. And what is the meaning of that one? With respect to ground. Okay. Now, if you apply KVL in this loop, then we got minus V2 plus V0 plus 0 volt is equal to 0. So V2 is equal to V0. So basically that V2 is V0 if that one is 0 voltage. Clear? That one is 0 voltage, then that one is V0. So V2 basically V0. So you can remove V2 and return simply V0. That is V0. Okay. Make it. After that, we are focused on apply KCL. Apply KCL at that node and that node. Now, apply KCL at node that is 1 and that is 2. So node 1 and node 2. Same voltage, that's why I written V1, V2. We have considered 1 and 2. Okay. If anyone day faced out, then tell me, I will explain again. Okay. So now next one, apply KCL. I don't know incoming current. No incoming current at that point. So all current are outgoing. I1 plus I2 plus I3. So written here, I1 plus I2 plus I3. This is equal to 0. That is KCL. That law is called KCL law. Okay. What about I1? I1 basically V1 minus 0 volt current leave from negative terminal, so minus 6 divided by how much? 4 kilo ohm. What about I2? I2 basically V1 minus 0 divided by how much? 12. And what about I3? 0. So what about I3? I3 is written as minus I3 is written as, if take LCM, then we got 12 multiplied by 3 V1 minus 18 plus V1. So what about that value? That is 4 V1 minus 18 divided by 12. So what about I3? I3 basically 18 minus 4V1 divided by 12. So 9 minus 2V1 divided by 6. Equation number 1. Okay. Okay. If taken 2 common, then we got like that one. 9 minus 2V1 divided by 6. That is equation number 1. After that, if you apply KCL at that node, then we got how much? I3, this will equal to 2 plus I4. Okay, 2 plus I4. And what about I4? That is 2 plus I4. I4 basically V1 minus 0 divided by how much resistance? 4 plus 12, that is 16. That is 16. That is I3. That is equation number 2. Okay. Now that value put in equation number 1. Okay. Then we got how much? 9 minus 2V1 divided by 6. This will equal to 2 plus V1 by 16. Okay. Now after that, 9 into 2V1 into 16. This will equal to 2 into 16 into 6. plus 6 into V1. Okay. After that, what about V1? Minus 2 into 16 into 2. That is how much? 32. V1. This is equal to written. That was 16 into, that is, sorry. 9 into 16 minus 2 into 16 into 6. This is equal to 6 plus 32 into V1. So V1 is written as 6, if 16 is common. Okay. So 9 minus 12 divided by 32 plus 6, 38. Then how much? Minus 16 into 3 divided by 38. Okay. After that, we got how much? 8 into 3, 24 divided by, so V1 is how much? Minus 24 by 19. Okay. Our motto, determine V0. So if you determine V0, means basically written, first of all, make it. Everyone make it. I know that if you see very carefully, V1 minus, what about I4? I4 basically V1 minus V0 divided by 4. This is equal to V0 minus 0 divided by how much? 12. Okay. So 12 divided by, that is 3 V1 minus V0. This is equal to V0. So 3 V1. This is equal to how much? 4 V0. So V0 basically 3 times 4, 3 by 4 into that value, put minus 24 divided by 19. Then what about that value? With the help of calculator, you can do. That is 3 into 24. How much? 72. 72 divided by 4. 18 divided by 19. Then how much? We got minus 0.947 volt. Make it. And recheck also my answer is clear or right or wrong. My answer is right or wrong. If anyone faced out, then tell me. I will explain again. Otherwise, I will take another problem also. If anyone faced out, corresponding to any step, then tell me. If anyone's phased out, then tell me. I will explain again. Okay. So how can do now? No, I will explain again one by one. So see very carefully. Our motto determine V naught. So how can do? First of all, we have taken branch current I1, I2, I3. Decide branch current like that one. After that, node voltage here V1, here also V1. Why? Because no any source connected between that two. And that one is V naught. And if this one is take reference node, after that, next target apply KCL at that node, and that node. Okay. I1 plus I2 plus I3 is equal to 0. I1 is basically V1 minus 0. Current leave from negative to so minus 6 divided by how much? 4 ohm. And what about I2? V1 minus 0 divided by that is 12 ohm. So 12 ohm plus I3 this is equal to 0. After we solve this, I3 we got 9 minus 2 V1 divided by 6. Okay. Next target, apply KCL at that node. I3 this is equal to 2 plus I4. I4 is written as how much? V1 minus 0 divided by how much? 16 volt. Sorry, 16 ohm. Okay. Now next is I3 like that one. Okay. I3 put in equation number. Wait. I3 this is equal to 2 times I2 plus I4. Okay. So I4 is V1 minus V0 divided by 4. Basically, if you see very carefully that one, look here. If you apply KCL at that node, I3 this is equal to 2 plus I4. I4 is V1 minus 0 divided by 16. Okay, clear? And after that, if you see, I4 is also written as V1 minus V0. Basically, after that one see, I3 is 2 plus V1 by 16 right now. And I3 is also like that one. So put here. Solving, we got V1 this equal to how much? Minus 24 by 19. And again, I4 is written V1 minus V0 divided by 4. And I4 is also written V0 minus 0 divided by 12. After solving, we got V0 this equal to, and V1 is put here, then we got like that one. This is the final answer. Make it. If anyone phased out, then tell me. I will explain again. Okay. I hope so clear. So otherwise, I will take another problem. If this one is clear, then I will take another problem. So now next problem is here. Sorry. Two resistance connected in series like that, and this one and another resistance connected here. Here voltage source minus and that one is plus connected here. Another voltage source connected here, plus minus. Okay, clear? And after that, what about voltage? That one is 12 volt, and that one is 6 kilo ohm. That one is 24 volt. Okay, that one is 4 kilo ohm. that one is 8 kilo ohm, that one is 4 kilo ohm. Our motto determine V naught with the help of nodal analysis. With the help of nodal analysis. Our motto determine V naught. What about V naught? Using nodal analysis. Nodal analysis. So how can do it? First of all, everyone try yourself. Okay? How can do, and after that I will do. Okay? Everyone try, then I will do. If anyone faced out, then tell me, sir, I faced out. I'm not understand about what are you saying. Please explain. So comment it, sir, I will not understand. If any doubt. Okay? Because your feedback is very important for me. Okay? I also clear. Look very clear. Okay? So using nodal analysis, determine V naught. If anyone faced out, then tell me, I will explain again. Okay? More doubt, more confusion. Sometimes more doubt, more confusion. Okay? So I hope so. How can do? So first of all, very simple. First of all, nodal analysis say always first decide branch current. Taken branch current. This one branch, that is total number of branches is 3. So number of current is 3. Okay, that one is I1. In this branch I2, and that branch I3. Second step, nodal analysis say node voltage. There are two nodes, here V1 and here V2. Third step say one node take reference node. So if this one is taken the reference node, means that one is 0 voltage. Okay. So that one is 0 volt. Okay. After that, apply KCL. Apply KCL. Now here also I2 current. Okay. If this one is 0 voltage, then it means that point voltage also V naught. Because here V not given. I have already discussed. Why? If this one is 0, then if V naught, this one is that voltage is V naught. So if anyone written that is V3. So V3 is basically V naught. Why? Because I have already discussed in previous question. So if anyone doubt, then go back and see again. So this one is written V naught. Now apply KCL. So written here, apply KCL at node 1, V1. Simply V1. If anyone faced doubt, then tell me, sir, I will not understand what or V naught. So if you understand, then tell me. If not understand, then go back in previous question. I have already discussed. Otherwise, clear? If clear, then no doubt. Okay. So apply KCL. Incoming current, no any incoming current. All current are outgoing. I1 plus I2 sum of outgoing current is equal to 0. I1 is written V1 minus current leave here. Initial voltage V1, final voltage 0. Current leave from positive terminal, so plus 12 divided by how much? 6 kilo ohm. And what about I2? I2 is written as V1 minus 0 divided by total resistance 12, 8 plus 4, that is 12. And what about I3? I3 is written as V1 minus 0, current leave from negative terminal, so minus 24 divided by 4 is equal to 0. After that, take LCM. Okay, that is 12. So if multiply by 12, then we got how much? 2V1 plus 24 plus V1. Here 3V1 minus 3 into 24 is equal to 0. So 2 plus 3 plus 1, that is 6V1. This is equal to 3 into 24 minus 24. So 2 into 24. So V1 is how much? 2 into 24 divided by 6. 4 2 ja 8. 8 volt. V1 is how much? 8 volt. Clear or not? If anyone phased out in any step, then tell me. I will explain again. Now next target is after that. What about I2? I2 basically V1 minus V0 divided by how much? 8, and that is written also V0 minus 0 divided by how much? 4. Okay. So V1 minus V0 is equal to 8 by 4, that is 2V0. So V0 basically how much? 3V0 is equal to V1. So V0 is equal to V1 by 3. That one is 8 divided by 3. So that one is written as 3 to the 6.7 volt is the right answer. If anyone phased out, then tell me, I will explain again. So final answer is 2.67 volt is the right answer. 2.67 volt is the right answer. If anyone phased out, then tell me, I will explain again. If anyone phased out, then I tell, comment it, I will explain again. Okay? If anyone phased out, then comment it, I will discuss again. Otherwise, make it. And check your answer. Your answer is right or wrong. Okay? Your answer is right or wrong. Make it. Everyone, if anyone phased out in any step, so frequently say, sir, I phased out corresponding to that part. I'm not understand, then I will explain again. Then I will explain again. Okay? I hope so. Your doubt, all doubt are clear. I hope so. Your all doubt are clear. Okay? Corresponding to that part, that question. Okay, so that is 2.69 is the right, 67 is the right answer. Okay? Now, so if anyone phased out, then I will explain again. So listen very carefully. First of all, branch current I1, I2, and here I3. we are assuming I1, I2 and I3. Okay. After that, apply and node voltage V1, and that is that node, take reference node. Apply KCL, I1 plus I2 plus I3 is equal to 0. No any incoming current at that node. All current are outgoing, so that's why. I1 is basically written V1 minus 0. Current leave from positive terminal, so plus 12 divided by how much? 6. What about I2? V1 minus 0 divided by sum of these two resistance. 8 plus 4, that is 12. I3 is how much? V1 minus 0, and that is current leave from negative terminal, so minus 24 divided by how much? 4 kilo ohm is equal to 0. After take LCM, then we got V1. Okay, that is 8 volt. After that, I2 is written as V1 minus 0 V0 divided by 8, that is, and this I2 also written as V0 minus 0 divided by 4. So V1 minus V0 this equal to V0. Solving these two, we got V0 is equal to 2.67 volt is the right answer. Okay. If anyone faced doubt, then tell me, I will explain. So I hope so your doubt is clear. So now next problem is, I have taken another problem. Then that one take current source, represent like that one. Here resistance connected, parallel resistance connected here. After that, plus minus a voltage source connected. After that is 4 kilo ohm. After that, a current source connected like that one, and that one is 3 kilo ohm connected, and another resistance connected here. Okay, our motto determine current in this branch, and that one is 3 milliampere, and that one is 6 kilo ohm, that one is 4 kilo ohm, that one is 3 kilo ohm, and that one is 6 kilo ohm, and that one is 3 milliampere, and that one is 6 volt. Okay, our motto determine I naught with using nodal analysis. Determine I naught using nodal analysis. Okay, and what about voltage? That is 6 volt, and that is 3 milliampere is given. So first of all, everyone try, then I will do. First of all, everyone try, then I will do. What about I naught? Our motto determine. What about I naught? Okay, so first of all, try everyone. Okay, now I also looking very, all data visual very clear. So how can do? Using nodal analysis. So clear, what is our motto? Determine I naught using nodal analysis. So first of all, we have considered branch current. Here I1, here I2, here I3, here I4, and here already given V naught, I naught. That one voltage V1, after the node voltage V2, and that one is V3, and that one is V4, and this one is ductum node, so this one is also 0 volt, and that is also 0 volt. Okay, clear or not? If anyone faced doubt corresponding to any step, then tell me, sir, I will not understand for you that part. I hope so. Visibility is clear. Okay. Now, how can do? So, what about nodal analysis? Nodal analysis first say branch, decide branch current. I1, I2, I3, I4. Next step is, what is our next step? Next step say node voltage, that is V1, V2, and here V3, and here V4, V5, V6. V4, V5, V6 are same voltage. Why? Because of no any resistance, any source connected in between. This one is ideal bias. Potential difference 0, potential difference 0. Now next step say one node take reference node. Reference node 0 voltage. If this one is 0, then also 0, that is also 0, because of no voltage drop between these two. So if this one is 0, that is also 0, that is also 0. Clear? Now apply KCL at that node, and that node. Before apply KCL, what the relation between V1 and V2? If you see very carefully, V1 minus V2, V1 minus V2, this is equal to how much? 6 volt. If anyone phased out, why you return 6 volt? Now let's check. This is one is given plus minus 6 volt, and here V2, here V1. Basically, what is the meaning of that one? This one meaning of plus minus 6 volt, that is plus minus, here plus minus V2, and here V1. If apply KVL in this loop, minus V1 plus 6 plus V2, this is equal to 0. So V1 minus V2, so V1 minus V2, this is equal to 6 volt. Clear or not? If this one is going on other side, then we got V1 minus V2, this is equal to 6 volt. So clear or not? So that is equation number 1. If anyone phased out, then tell me this statement is clear or not. This statement is clear or not? Okay, if anyone phased out corresponding to that one, say I will explain again. Okay. If anyone phased out, sir, I will not understand about that point or that point, any point, then I will explain again. I hope so everyone can understand. Okay. Okay. If anyone phased out, then tell me, I will explain again. I hope so. No any problem regarding to that one. So move forward. Okay. So this one remove. Now after that, apply KVL. Sorry, KCL. Apply KCL at node. Which node? V1, V2, V1, V2, and V3. Okay. Apply KCL here. Incoming, no any incoming current, all current, this one, and this one are outgoing current. So 3 plus I1 plus I2, this will equal to 0. Okay. 3 plus I1 is V1 minus 0 divided by 6. I2 is, what about I2? No idea. So simply written here, I2 this will equal to minus 3 minus V1 by 6. Equation number 2. Now apply KCL at that node. Incoming current I2 and 3. So I2 plus 3, this will equal to I3. I2 is how much? Minus 3 minus V1. Minus 3 minus V1 by 6 plus 3. Okay. That value put here. This will equal to I3. I3 is how much? V2 minus 0 divided by how much? 4. 4 kilo ohm. Okay. 3 and 3 are cancelled out. And that is, what about relation between V1 and V2? So V2 is written as 4V1 divided by how much? Minus 4V1 divided by 6. So minus 2V1 divided by minus 2V1 divided by 3. If this value put in equation number 1, then we got what is the relation between V1 and V2. Okay. Then we got relation between V1 and V2. If that value put here, so V1 minus, if that value put here, then we got 2V1 divided by 3, this is equal to 6. So 5V1 is equal to 18. 3 plus 2, that is 5V1, this is equal to. So what about V1? V1 this is equal to, sorry, V1 is 3.6 volt. Okay. If that value put in equation number, we put that value here, then we got how much? Minus 2 by 3 into 3.6 minus 24 minus 2.4 volt. Okay. V2 is how much? 2.4 volt. But our motor determine I0. So how can we determine I0? If apply KCL at that node, incoming current, no incoming out current or outgoing, so 3 plus I4 plus I0, this is equal to 0. So 3 plus I4 is V3 minus 0 divided by 3, and I0 is written as simply V3 minus 0 divided by 6, this is equal to 0. Okay. Basically, so if this one is removed, then we got, sorry, take LCM, then we got, if you multiply by 6 in both sides, then we got 18 plus 2V3 plus V3, this is equal to 0. So we got 3V3, this is equal to 8 minus 18. So V3 is how much? Minus 6 volt. Our motto determine I0. So I0 is basically V3 minus 0 divided by 6. So minus 6 divided by 6. So minus 1 milliampere is the right answer. Simple. Basically simple. If you apply here nodal analysis, only this portion, then we got result. No any need corresponding to V1, V2. Okay. Simply apply nodal analysis here. Then we got, actually our motto, what is our motto? Our motto determine I0. So you apply KCL at that node. Then we got this one. After solving, we got V3, this equal to something. And I0 is basically V3 minus 0 divided by 6. So put here, then we got V3 is, I3 is how much? I0 is how much? Minus 1 milliampere is the right answer. If anyone faced doubt, then tell me, I will explain again. Okay. if anyone faced out. Okay. So first of all, make here okay. I hope so. Your all doubt are clear corresponding to our numerical problem, circuit problem basically, on the basis of nodal analysis. So tomorrow I will take another best problem according to nodal analysis. How can apply nodal analysis on some difficult problem corresponding to electrical circuit. Okay. So if anyone faced out, then tell me that I faced out corresponding to that step, then I will explain. Otherwise, if you have problem, then send me in one WhatsApp number +919041398104. Okay, I will explain. I will take and then solve and send you WhatsApp. Okay, so today class is finished. Tomorrow I will take next nodal analysis based some complex problem. So thank you very much for joining and send me feedback. Your feedback is also important for my side, for me. If you send me feedback, is your class is okay, it's you're fine, excellent, whatever we feel. And if you not understand, then also complain. Sir, I will not understand. What are you saying? Then I will improve my presentation. Your feedback is very important for me. Okay, so I hope so. Thank you very much. Today class is finished. Okay.